Solutions, and our project is SmartPlug Bluetooth button transmitter and receiver. Our technical directors are Robert Killicker, Philip Manning, Nick Costello, and Mike Smith. Our team, this is myself, Designer 1, Andrew Nebraska, Electrical Engineering major, Designer 2, Matthew Marino, Electrical Engineering major, Designer 3, Danny Sosa, Computer Engineering major, and Designer 4, Michael Correa, Electrical Engineering and Computer Engineering major. Our company is family-owned manufacturer headquartered in Capstone, Rhode Island. They sell and make affordable products that save energy, which include heating, cooling, plumbing, and irrigation products. They also have facilities all over the world, including Vietnam, Switzerland, and Italy. Our product motivation is for low-power Bluetooth communication to save energy without wasting too much water, and smart learning with a phone application. The market in which we are targeting includes homeowners, business owners, and water authorities, and also places of interest include areas with significant droughts and areas with limited hot water or water supplies in general. Also, this pump must be manually turned on, and no device learning must be allowed for some states, which include, for example, California, because so much water is not of use or not available in California, which means that we need to save as much water as humanly possible. Best anticipated outcome for this project includes key features for the SmartPlug and the prototype button board, which includes Bluetooth communication for both the SmartPlug and prototype button board. For the SmartPlug, control SmartPlug with functionality via GPIO and drivers, and update the SmartPlug firmware to provide on-demand recirculation functions. For the prototype button board, coin cell battery operation for 5 to 10 years, and push button as well. Because, like I just stated before, we need to manually start the process as opposed to having device learning. Team key technical accomplishments include connection between the Sager, Feather, and prototype button board, and the Sager was used to put code onto the Feather and prototype button board, or the module that is on both of those, to install and update bootloaders, Bluetooth low energy tests on all 8 different Feathers, verified prototype sketches for SmartPlug and button, soldering and desoldering on the SmartPlug and button board, and corrections to the SmartPlug schematics and calculations. Economic impact for the company. With the development of this device, TACO would realize increase on demands and recirculation product sales in the range of $380K to $475K annually, but could be more or less depending on how the demands turn out. This is the simple dot block diagram of the project, which includes the button, the SmartPlug, and the pump. And on the right side, this is the software that will be included into it, and once the timer begins or once the button is pressed, these are all the outcomes that could possibly happen. Next are my technical accomplishments, which first I'm going to talk about schematics and calculations. For the schematics, I gained an understanding and organized the schematics. As you can see on the right side, that's a picture of the schematics. And I made necessary changes based on feedback we received from our technical directors, which include different resistors that need to be changed out or different components that need to be changed out, and whether or not we can implement some circuitry through software. And also I made calculations as well, which you can see on the left side, and those were hand calculations based on to check the validity of the SmartPlug circuitry. Next, I did SmartPlug soldering, and I did soldering and desoldering for the SmartPlug as well, based on components in which we felt were necessary or unnecessary to help with the functionality of the SmartPlug. As you can see on the right side, I circled the R1 and R8, and that was because those were the two that we worked on the most. R8 was taken out altogether, and R1 was switched with a 3.3K resistor. Next is offboard testing. I tested the circuitry of the SmartPlug. On the right side, top right, is the picture of the thermistor circuitry. On the bottom is the LED error mode and power circuitry. And these were just as tests to see if these circuits had worked and to make sure that the validity of the circuitry was correct. And also the mode button was another circuitry that we had tested as well. And next, I had helped with some testing and soldering and desoldering in the prototype button board, but that was mostly designer Matt Moreno's job. But he needed some assistance on some things, so I just assisted him with testing, soldering and desoldering, and then finding connections as well. And expected technical accomplishments towards ABO, I expect to do onboard testing for the SmartPlug, corrections to the schematics on pads, fully functioning prototype for the SmartPlug and button board, and Bluetooth interaction between the prototype button board and the SmartPlug, and design casing for the prototype button board. Next will be designer 2, Matthew Moreno, and that's his picture in the bottom right-hand corner.
Similar to my teammate before me, I'm also an EE student, and one of my main technical accomplishments throughout my time working on the SPBBTR is the testing and repairs made to the prototype button board. For starters, I was able to find the proper connection between the button board, the breakout board, and the J-Link Seeger by using the schematic that Takeo themselves provided for our team. Along with making these connections, I also made some repairs on the board as the USB port that initially came installed had broke. Lastly, when talking about the prototype button board, I was able to find the lines that the pins on the USB were connected to by locating the continuity between pins and position on the board. Another one of my technical accomplishments was updating the bootloader on the Adafruit NRF 52840. In order to do this, I first needed to figure out how exactly the Seeger and the feather were supposed to be connected. Once that was done, I was able to track down the latest firmware for the feather on GitHub, and using the tool provided on the Nordic site, it allowed for me to overwrite the hex files containing the different versions of the firmware, updating it from version 0.3.2 to 0.6.2. Lastly, I was responsible for getting the communication between the button and receiver working. To start out, we began by uploading a low-energy Bluetooth demo to one of the feather units we had, allowing it to function as a beacon for our smartphones to recognize. Once this code was installed, using yet another Nordic tool, we were able to confirm that the BLE mode on the feather functioned as intended, as the app would display a picture of the Mona Lisa the closer it got to the feather unit itself. Once I was able to confirm the Bluetooth was properly functioning, I began to verify the codes provided by Takeo for both the button and receiver to make sure that I had no errors. Once verified and uploaded to the two feathers we were going to use, I began to monitor them on the Arduino IDE. When the button on the button feather was pressed, the receiver feather would acknowledge the button press, confirming that we had successfully gotten the codes communicating. What I hope to accomplish before the end of the capstone is to implement the changes asked of us by Takeo in regards to the schematics, which will hopefully allow for us to have a fully functioning button board and receiver, which will allow for us to begin the final sketches so that we may start finalizing the SmartPlug design and hopefully have a working alpha before the end of capstone. This concludes my section of the presentation, and I'll now pass it over to Michael Correa.
Thank you, Matt. I'm Michael Correa, and my focus is on the computer engineering side of this project. We inherited a few prototype sketches being the word for code written in Arduino, from last year's team. As such, I had to analyze and understand each sketch before I could attempt to manipulate them. In that vein, I had to seek out libraries for our Adafruit devices, ensuring compatibility between them and Arduino. The next step was to compile the sketches and to verify that there were no issues with syntax. After that, with the help of Matt Moreno, I was then able to upload the sketches onto the Adafruit feathers and use the Arduino serial monitor to observe the successful transmission of a button press. With that out of the way, I began what will perhaps be my most significant contribution to this project, low power mode. While conducting research, I found that no such library exists, so I would have to get creative. I came across delays, wait for event, and wait for interrupt. To better understand how these functions operate, I used example sketches and then created new sketches without the Takeo firmware to put the feather to sleep. Now came time to incorporate what I learned into the prototype sketches. It took some time and consultation with our technical directors to figure out where to place the new code and how to implement it step by step. In the midst of this came the need for additional features, a counter to record errors and the transmission of a message describing the nature of the errors, a 24 idle timer that will let the SmartPlug know that the button is still alive, and a connection message. Unfortunately, I have yet to successfully implement these concepts, but I have made progress in developing the structure of the code. In the coming semester, I expect to successfully implement low power mode, the connection message, an error counter and error message, and a 24 idle timer and idle message. Having done so will help put my team in position to have a product available for alpha testing. And now, I pass the baton to the last member of our team, Danny Sosa.
Similarly, as my teammate who is also a CPE major, I worked on the firmware side. My technical accomplishments include assisting with the analysis of the prototype sketches, along with understanding how the code operates on a deeper level and what to expect when testing. As well, I installed all the necessary Arduino IDE libraries to make sure everything was compatible with the Adafruit NRF 52840 Feather Express. Then tested and verified that the sketches uploaded to the Feathers worked as intended. With the help from the EE team member, we noticed that the Arduino serial monitor confirmed that the SmartPlug board received button press from the button board. One of my technical accomplishments was working on the firmware where I implemented battery level, giving the user an advantage to check and monitor the button board battery percentage. In addition, I also implemented signal strength so the user has the ability to be connected to the SmartPlug at all times within their homes. Instead of having to be close, they can be at a wider range. Adding features to the battery level where it can send the user a warning that it is at 20% and continue sending warnings as it decreases every 5%. As a result, this will aid the user to plan ahead and get a battery replacement before the battery is no longer functional. Enhancing the signal strength will give better reception, while implementation of the 7-day learning schedule, the button will send a message to let the SmartPlug know it's time once it learns the user's shower patterns. For our key future technical accomplishments, for the hardware, there needs to be changes to the schematics and SmartPlug layout and pads. Then upload the Arduino sketches to the SmartPlug and prototype button board. Lastly, on the board testing, the SmartPlug and prototype button board to confirm they are functioning as intended and get them to communicate with one another through Bluetooth. On the software side, low power mode along with 24-hour timer, error counter, transmit error counter value and error message needs to be implemented from the button board to SmartPlug along with transmitting battery level and signal strength from the button board to SmartPlug. Overall, our confidence level towards ABO is moderate, taking into account the risk tracking factors such as extreme weather with the likeliness of low, seriousness of low, and graded as D, as well as scheduling conflicts with the likeliness of low, seriousness of low, and graded as a D. And lastly, COVID-19, with the likeliness of medium, seriousness of medium, and graded as a C. We want to thank all our technical directors who have supported and guided us in the right direction. Robert Kelleger, Philip Manning, and Nick Casilla. We also want to thank you, Dr. Sunak, for making this all possible. And thank you, Mike Smith, for being there when we needed you. Once again, thank you.